Solving quadratic functions. Let's recall that the discriminant is b squared minus 4ac, and when that discriminant is larger than 0 with a positive number, we have two unique real roots. When the discriminant is equal to 0, we have one repeated real root. And then when the discriminant is less than 0 with a negative number, we have two imaginary roots. Let's recall the steps to factoring from our previous notes. Remember, the first thing you want to do, step 0, would be to factor out the greatest common factor if possible. And then step 1, identify A, B, and C. Okay, the next step, you're going to draw an X. A times C goes at the top, B goes at the bottom. Then we're going to find two factors such that B1 times B2 equals AC, and then B1 plus B2 would equal B. The next step, we want to find those those B1, B2s, list factor pairs of AC. And then step 4 would be find the sums of each factor pair. And then step 5, we would have X plus B1 times X plus B2, and we're going to divide each of those found factors by A. And then the last step would be simplify the fractions and slide denominators to front. Okay, let's do the first example. Solve. Your answer should look like x equals and then something. So we have x squared minus 6x plus 9 equals 0. Well, it's set equal to 0, so that's part of the first step. There's no greatest common factor besides 1, so we don't have to do that step either. So we're going to identify A, B, and C. A is 1, B is negative 6, and C is 9. So A times C will be 9, and B is negative 6. We're going to write out the products of 9. So 1 and 9, 2, which is a decimal, and then 3 times 3. Now this is negative, so both of your numbers are going to be negative here. So we have negative 10 for our sum here, and negative 6. It's going to be the second factor pair that works. And so then we have x minus 3 times x minus 3 equals 0. We're going to set each of these equal to 0 separately, each factor. Add 3, add 3, add 3, add 3. So x just equals 3. So we have one repeated real root. Let's look at the next one. X squared minus 5x minus 6 equals 0. It already equals 0, and there's no greatest common factor besides 1. So we just go ahead and identify A, B, and C. A times C would be -6, and B is -5. Let's write out the factor pairs of -6. The bigger number is going to be negative, and the smaller number is positive. You can refer back to the previous notes to help you identify that. It's the first factor pair that works here. So we'll go ahead and write that on the sides. So we have x minus 6 times x plus 1 equals 0. Set each of them equal to 0 separately. Okay, so let's set each of these factors equal to 0 separately. Add 6, so x equals 6. Subtract 1, x equals -1. So we have -1 and 6 for our two roots. Let's look at C. 5x squared plus 2x minus 3 equals 0. It already equals 0, and there's no greatest common factor to factor out besides 1, so we can go ahead and identify A, B, and C. A would be 5, B is 2, and C is -3. So A times C is -15, and B would be 2. We're going to find two numbers that multiply to give you -15 and add to give you 2. Let's write out the factor pairs of 15. We have 1 and 15, 2 which would be a decimal, 3 and 5, and then 4 would be a decimal too. We have a negative up here and a positive down here. That means that we're going to have the bigger numbers positive, the smaller numbers negative. Let's find our sums. We have 14 and 2. So it would be the second pair that works here. So then we have x plus 5 times x minus 3 equals 0. Remember, we also want to divide by a. Since a is not 1 here, we have to show that. Simplify the fractions as much as possible. So we have x plus 1 times x minus 3/5 equals 0. Now, if we're just asked to factor this, we can slide that 5 to the front and we'd be done. We don't have to do that for solving, though. We could just go straight to say each of these factors equal to 0 separately. So, subtract 1, x equals -1, add 3/5, x equals 3/5. So our two solutions are -1 and 3/5. Let's look at D. 6x squared minus 11x plus 4 equals 0. There's no GCF besides 1. It is already set equal to 0. So we'll just identify A, B, and C. 6, -11, and +4. A times C would be 24. B is -11. Let's write the factor pairs of 24. So we have 24 and 1, 12 and 2, 8 and 3, 6 and 4, and then 5 would be a decimal because 24 divided by 5 is a decimal. There's positive up here, so we'll have the same signs, and they need to be negative because your sum is a negative number. Let's write out the sums. So it looks like that third pair works. -8 and -3. And then we have x minus 8 times x minus 3 equals 0. We have to divide by a since a is not 1, so we have to show that. Reduce the fractions as much as possible. You have x minus 4/3 times x minus 1/2 equals 0. 8 and 6 both go into 2. Half of 8 is 4. Half of 6 is 3. 3 and 6 both go into 3. 3 divided by 3 is 1. 6 divided by 3 is 2. We'll set each of these factors equal to 0 separately. Add 4/3. So we have x equals 4/3. And then add 1/2. X equals 1/2. So your two solutions is 1/2 and 4/3. So let's go over the steps of solving a quadratic equation by factoring. You want to see if you can take out a greatest common factor, and you want to make sure that the equation is set equal to 0 and not some other number. After you've done those two things, identify A, B, and C, draw your x, list your products of AC and the sums of those pairs, those factor pairs, figure out which pair works. Write your factors, divide by A, simplify the fractions as much as possible, and then set each factor equal to 0 to find your two solutions. Simplify square roots. If there is a negative inside the square root, put an I on the outside and get rid of the negative sign. Factor out perfect squares, 4, 9, 25, 49, etc. So let's look at the first one, the square root of 80. There's no negative, so there's not going to be an I in your answer. Let's first see if we can pull out a 4. 80 divided by 4 is not a decimal, so that means we can factor it out. 80 divided by 4 is 20. We can pull out another 4. 20 divided by 4 is 5. We can't pull out another 4 out of 5, and we can't pull out 9 because 9 is bigger than 5, so that'd automatically be a decimal. So we'll just rewrite this expression as the square root of 4 times the square root of 4 times the square root of 5. The square root of 4 equals 2. This square root of 4 also equals 2. The square root of 5 is an irrational number, so we just leave it inside like that. 2 times 2 is 4. So our simplified radical is 4 square root 5. So the square root of 80 is the same thing as 4 square root 5. 4 times 4 is 16. And 16 times 5 would be 80. Let's look at the next one. The square root of 72. There won't be any I's on this one, but let's see if we can pull out a 4. We can. 72 divided by 4 is a whole number. It is 18. We can't pull another 4 out of 18, but we can pull out a 9. 9 times 2 is 18. We can't pull any other perfect squares out of 2 because they're all bigger than this 2. So we'll just rewrite this as the square root of 4 times the square root of 9 times the square root of 2. The square root of 4 is 2. The square root of 9 is 3. And the square root of 2 is irrational, so we just keep it as square root of 2. 2 times 3 is 6. So 6 square root 2 is our simplified expression. So the square root of 72 reduces to 6 times the square root of 2. 6 times 6 is 36. 36 times 2 is 72. That's how you can check your answers. Let's look at G, the square root of negative 48. It has a negative, so we could pull out a negative 1 right here. We can also pull out a 4. 48 divided by 4 is 12. We can pull another 4 out of 12. 12 divided by 4 is 3. We can't pull out any other perfect squares because they're all bigger than 3. So we can rewrite this as the square root of negative 1 times the square root of 4 times the square root of 4 times the square root of 3. The square root of negative 1 is I. The square root of 4 is 2. The square root of 4 is 2. And the square root of 3 is irrational, so we leave it alone. So 2 times 2 is 4. We have 4i square root 3. That's our simplified expression. So the square root of negative 48 reduces to 4i square root 3. Sometimes they write the I at the end. Either of those would be acceptable to me. Let's look at h, the square root of negative 24. We have a negative, so we can pull out that negative 1. We can also pull out 4. 24 divided by 4 is 6. There's no other numbers we could pull out. 6 divided by 4 would be a decimal. And 6 divided by 9, 9's bigger, so it's automatically going to be a decimal. So we can rewrite this as the square root of negative 1 times the square root of 4 times the square root of 6. The square root of negative 1 is I. The square root of 4 is 2. And the square root of 6 is an irrational number that can't be simplified. So our simplified square root is 2i square root 6. So the square root of negative 24 reduces to 2i square root 6, also known as 2 square root of 6i. Either one of those. Let's look at these examples. Solve quadratics using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The stuff that's inside the radical is called the discriminant. We talked about it a little bit at the front of this notes foldable. So if you can't factor something, like for example, if you look at this one, a is 3, b is negative 6, and c is 7. If we try to factor this, we would have 21 and negative 6. If we were to write the factored pairs of 21, decimal, 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 the bigger number would need to be negative and the smaller number positive. Notice that neither of these sums give us negative 6, so you can't factor it. So the next thing to do is to use the quadratic formula to find your roots. So after we identify a, b, and c, we'll plug them into the formula. B is negative 6, so wherever we see a b in the formula, we're going to put negative 6 instead. Wherever we see an a, we're going to plug in 3 instead into the formula. And then c will be 7. So we have x equals negative negative 6 plus or minus the square root of negative 6 squared minus 4 times 3 times 7 all over 2 times 3. Let's reduce this a little bit. We have 6 plus or minus the square root of 36 minus, so that's 21. 21 times 4, 84, all over 6. And then we have 6 plus or minus the square root of negative 48 all over 6. If you look from before, the square root of negative 48 is 4i square root 3. 6 plus or minus 4I square root 3 all over 6. Let's make a note of this. So then we have, we can factor out a 2 since both terms at the top are even numbers. And 6 is the same thing as 2 times 3. The 2's cancel out. So there you have your solutions. 3 plus or minus 2I square root 3 all over 3. Let's look at J. We have 6x squared minus 12x plus 10 equals 0. All three of these terms are even numbers, so that means we can factor out a 2. 6 divided by 2 would be 3. So we have 3x squared minus 6x plus 5, and then that equals 0. So again, to get each of these numbers inside, we divide it by 2. If we divide each side by 2, we still have 0 on the right side, but now we have a more simplified expression on the left side. Identify A, B, and C based off of that. So A is 3, B is negative 6, and C is 5. If you were to put the original numbers into the quadratic formula, you would still get the same answer. It would just involve more simplified in the process. So let's plug those in. So I'll plug in A, which is 3. B is negative 6. And then C is 5. So we have x equals negative 6 plus or minus the square root of negative 6 squared minus 4 times 3 times 5 all over 2 times 3. Let's simplify this a bit. So two negatives multiply together, cancel out. We have 6 plus or minus the square root of 36 minus 4 times 3, which is 12. 12 times 5 is 60. All over 6. And then we can reduce that further. We have 6 plus or minus the square root of negative 24 all over 6. To see this one simplified, refer to example H for simplifying. So if we look back at H, the square root of negative 24 is 2I square root 6. So we have 6 plus or minus 2I square root 6 all over 6. Just like the previous example, these are both even numbers, so we can factor out a 2. 6 divided by 2 is 3. 2 divided by 2 is 1. And 6 is the same thing as 2 times 3. These 2's will cancel. And we don't have to write this 1. So our solutions are 3 plus or minus I square root of 6 all over 3.